Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we introduce logarithmic functions. So, we're looking at the logarithmic function with base b. So, for x greater than 0, b greater than 0 but not equal to 1, y equals log base b. That's the logarithmic form. It's the same as b to the y equals x. Now we know in an exponent here b represents the base. So the base in this exponent is the same base that's in that logarithmic expression. Y equals log base b of x is the same as b to the y equals x. Let's look at an example. We have 3 equals log base b of 27. That's the logarithmic form, and we want to write the exponential form. So y here is 3. B here is just b. So we have b to the y equals x. X is the argument of that log, which is 27. In the next problem, we have 5 to the negative third power equals 125. So this is the exponential, and we want to get the this is the exponential form, and we want to get to logarithmic form. So we have b to the y equals x. So here y is negative 3. Our base is 5. And our argument is 1 over 125. So some characteristics of the logarithmic function. The domain is 0 to infinity, and the range is negative infinity to positive infinity. If you remember, we had a lecture on the exponential function, and we said that the exponential function was 1 to 1, therefore had an inverse function. Well, the logarithmic function is the inverse of the exponential function, which means that the domain and the range of those two functions switch. So here we have a restricted domain of 0 to infinity, which means that when we start to solve logarithmic equations, we're going to have to check our solutions. The range is in negative infinity to infinity. We have an x-intercept at 1, 0. We don't have a y-intercept. If b is bigger than 1, it is an increasing function like this left-hand side. If b is between 0 and 1, it is a decreasing function like the right-hand graph. The y-axis, or x equals 0, is a vertical asymptote. And we also have a point b, 1 on both graphs as well. So let's find the domain of some logarithmic functions. We have log base 5 of x plus 7. So remember that this expression that we're taking a log of has to be greater than 0. So here x is greater than negative 7. And the way we write x being greater than negative 7 in interval form is negative 7 to infinity, open at negative 7. Next we have log base 3 of 6 minus x. So 6 minus x has to be bigger than 0. Let's subtract 6 from both sides. If we multiply both sides by negative 1, the direction of the inequality reverses. And we have x being less than 6, which in interval notation is negative infinity to 6, open at 6. Now, there are going to be times when we need to probably get a decimal approximation of a base that's not 10 or not e. Base 10 is the LOG button on your calculator with no base. LN, which is lowercase l, lowercase n, that is another log, but that's base e. So if we have log base b of m, then we can change it to either base 10 or base e and get a decimal approximation on our calculator. So here, if we want to change this to any base, log base b of m to base a is log base a of m divided by log base a of b. Here, if you want to change it to base 10, log base b of m is log of m over log of b. If you want to use natural log, log base b of m equals natural log m over natural log b. Let's look at an example. Let's change the base, and we're going to go ahead and we're going to change this to base 10 and base e, just to show that you will get the same answer. So log base 10 of 19 to base 10 will be log 19 over log 6. And if you put that in your calculator, you should get a decimal approximation of 1.64. Then if we look at log base 6 of 19 and we want to do natural log 19 over natural log 6, again, you get 1.64. So it does not matter which one you change the base to, whether base 10 or base e, you'll get the same result. So remember that Dr. LB is always in. Please come back for more math help.